Hello, this is Mr. Collier, and today we're looking at antidifferentiation, which is basically the opposite of differentiation. So to get started, let's review a couple of basic derivatives. So if I get the derivative of 2x, just a constant times x is just going to be the constant, so like 2. Derivative of e to the 2x is going to be 2 times e to the 2x, okay, because you've got chain rule, you've got to multiply by 2. Here you're going to use power rule, and you're going to get 2 times 2 is 4x. Okay, that 2 gets multiplied by this 2, and the exponent reduces by 1. This is the same as x to the power of 3 over 2. So when we get the derivative, it's 3 over 2x to the power of half. Reduce the exponent by 1. So that's 3 over 2 root x. Here the constant 4 is going to go away, and the derivative is just 5. For this one, we want to simplify first. So this is x to the power of 3 divided by x to the power of half is x to the power of 5 over 2. And x to the power of 2 divided by x to the power of half is x to the power of 3 over 2. So when I get the derivative, I have to do 6 times 5 over 2 x to the power of 3 over 2 minus 5 times 3 over 2 x to the power of half, which is 15x to the power of 3 over 2 minus 15 over 2 x to the power of half. So that's just a couple review of a couple of derivatives. Now when you do integration or antiderivatives, you go backwards. So we're given this, the derivative of what function gives us this function, right? So when we look for that function, we know the exponent has to be 1 higher, so it has to be a 2. And it was multiplied by 2 to get you 4, so you had to divide by 2, and then you get a 2. So I'll show you what that looks like over here. So like this one here, whatever the original function was, it had to have x cubed. The exponent of x had to be 1 higher. And 3 times whatever the coefficient was gives you 6, so we have to divide by 3 and get 2. Right, so that makes sense. The derivative of this one is this one. This one here is just a constant, so when you integrate, it must have been just 5x, because the derivative of 5x equals this. And over here, it might be easiest to rewrite this as 2x squared minus 7x to the power of negative 1. Okay? So 2x, so it must have been x cubed, okay, and it must have been multiplied by the coefficient must have been multiplied by 3 to get you 2, so it's got to be 2/3. 2/3 times 3 gives you 2. Now the second one, we've got a constant of 7. Now if we look at x power negative 1, it's like 1 over x. So the derivative of what gives you 1 over x? Well, that's simply ln x. Okay? Simply ln x. And let's look over here. We have x to the power 9, so you increase the exponent by 1. It's kind of the opposite of differentiating. And then you have to divide this coefficient by 10. So 5 divided by 10 is half. Okay, and for the e, the derivative of e to the 3x is e to the 3x times 3. So if I do the integrating, I got to do a divide by 3. So we get that. Okay, now this is interesting because you got a derivative equals 0. So this has to be a constant. It could be any constant. So we'll call it c to represent any constant. You're going to see that a lot more later. Now over here, just do it term by term. This should be an x cubed minus 4 e to the x, that's the same, and this is minus 5 ln x. Okay, now over here, let's expand the brackets. That will make it a lot easier. So we got x cubed plus 8x squared minus 3x squared, and then minus 24x. Again, this is like a 5x squared. So when we get the integral, we increase the exponent by 1. That means we have to divide by 4. Then for the next one, we increase this exponent by 1, looking at the 5x squared. And then we have to divide by 3, so we're going to have 5 over 3. And for the negative 24x, we increase the exponent by 1, and we divide 24 by 2, and we get 12. So that's the antiderivative of that one. Okay, so finding the antiderivative is the opposite of differentiating, yes. So this is kind of like a power rule. Okay, it's just like what we did. We increase the exponent by 1, then we divide by that exponent. So that's what I was just doing a bunch of times. Now it's plus c. Let's go back to this one, because I'll explain that now. Yes, the derivative of this is this function over here, 6x squared. But you can have any constant here. You could have a plus 3, or a plus 2, or plus e, or plus pi. The derivative of that is going to be 0, so you still get the same derivative. So that's why we say the antiderivative is 2x squared, 2x cubed plus c, because any constant that's differentiated just goes away. So you can write all of these with a plus c. Okay, so that's where that plus c comes from. So these couple of ones here, we kind of already did a bunch of them. Let's just do that again. So this is a quarter times x to the power 4. And e to the x just stays e to the x. And this is minus 3 times the log of x. Okay, now notice that when you log x, you can't log a negative number or 0, right? So actually the integral of 1 over x is actually ln absolute value of x. Okay, and you can put a plus c here too. Here this function is the same as 2x to the negative 3. So if I want to find the original function, you increase the exponent by 1. That's a negative 2. Then I have to divide by negative 2, so I get a negative 1. And then you get a plus c always. Okay, the next one, you can do the same thing if you have a linear factor. If this is x squared or something, you can't do that. Only if you have a linear factor, just x in there. Okay, so it works the same as before. You increase the exponent by 1, and well, this is the derivative. So when I do the integral, increase the exponent by 1, and then divide by that exponent. And then we have, by chain rule, we have an extra constant. We have to divide by a. So over here, yeah, we increase, when we want to find y, we increase the exponent by 1. So that's a 4. Then we have to divide by 4. And we have to divide by a 2. Okay? Because when we differentiate, we have to multiply by 4 and we have to multiply by 2. So integrating is backwards, so we have to do that. So it's like 1/8 2x plus 1 to the power 4. This function, we can write it as this. So we integrate, we get the antiderivative. We increase this exponent by 1. Okay, that becomes 3 over 2. Okay, that means we divide by 3 over 2, which is the same as multiplying by 2/3. And then we have to divide by 3, which is the same as multiplying by 1/3. So that is 2 over 9 times 3x minus 5 to the power of 3 over 2. Now this one here we can write as 2 times 4x minus 3 to the power of negative 2. So when we integrate, we will increase the exponent by 1. Then we have to divide by a negative 1. That's that. And we have to divide by 4. So that equals, we got negative half. And we can, this is to the power of negative 1, so I just write in the denominator 2x minus 3. Or sorry, 4x minus 3. Okay, so that's what we get. Let's take a look at a couple more. Let's consider the derivative of that. So the derivative of that is ln. So it's 1 over 5 minus 3x plus x squared. Chain rule means you multiply by 2x minus 3. Okay, so this is almost 2x minus 3 here. By the way, this symbol I haven't introduced yet. This means the antiderivative or the integral. Okay, we'll see more of this later. Okay, so we can write this as 2 times the integral of 2x minus 3 over 5 minus 3x plus x squared. And that means the answer is just 2 times this. So 2 times ln 5 minus 3x plus x squared. Okay, similarly we can do this one here. The derivative of 2 to the power of x, it's sort of like e to the x, remember? We did this last unit, but you got to multiply by an extra ln 2. Okay, so that means when we do the integral, we have to divide by ln 2, so it's going to be 1 over ln 2 times 2 to the x plus c. I forgot the plus c over here too. You always have to add the constant.